This is the third part of our counting rules, and in this lesson I will explain to you about combination rule. But one more time I will explain you that in order to find out the all possible outcomes. See, the focus is on the word all possible outcomes for the sequence of an events. Suppose if you have 3 events, if you have 4 events or 5 and so on, and if you want to find out all possible outcomes of those events, then you have to use these 3 rules. So fundamental counting rules we have discussed in lesson number 1. Then we move on to permutation, and this is the third part, which is the combination rule. So first I will explain to you combinations, then I will show you with the help of example. A selection of distinct objects without regard to order. See, in combination there is no need of order. It's called the combination. Order of selection is not important. In the case of permutation, yes, order is important, but in combinations order is not important. Here I have set a little example. Suppose you have 100 students in a class and you want to pick any 10 out of 100, right? So it does not matter who is selected first, second, third, and so on. This is called the combination because there is no need of the order. Combination are used when the order or arrangement is not important, as in the selecting process. Suppose 10 students is to be selected from 100 students. As a member of the student council, 10 students represent a combination, as it does not matter who is selected first, second, and so on. So simply you can say in combination order is not important. So here I will show you with the help of formula how to calculate the combination. The number of combinations of R objects. R means whatever is the requirement from the n objects. N means total number of objects. Suppose you have 3, 4, 5, and out of 5, how many is the requirement, 3 or 4 or 5, right? So the formula is NCR. Again, N is the total number and this one is the required number. R represents the required number, N is the total numbers of the object, is equal to N factorial divided by N minus R factorial. R factorial, this is the important thing, that you have to use the factorial, and this is the factorial symbol which you will find on the top of 1, on the top of 1 on your keyboard, right? You have to press shift and 1, so you will get this factorial symbol. You have to use factorial in combinations as well as in permutation as well. Factorial means, if I will say 3 factorial, it does not mean that you have to write down 3, means 3 multiplied by 2 multiplied by 1. From 1 to that number you have to multiply. If I will say 4 factorial, right, starting from 1, then 2, and then 3, and then 4. You can start from 4 as well. This is the 4 factorial, sorry, this is the exclamation mark which represents the factorial. 4, this dot represents multiplication. 4 multiplied by 3 multiplied by 2 multiplied by 1. When you have to multiply all these numbers, you will get the answer of 4 factorial. So here is the 5 factorial. Total number of objects are 5. N minus R, 5 minus 3 factorial, and then R again is the 3 factorial. So 5 factorial, I told you, starting from 1 to 5. You can start from right to left or left to right. So if you will start from left to right, then you have to start with the number 5, 4, 3, 2, 1 in the descending order. But if you will start from the right, you have to start in the ascending order, 1, 2, 3, 4, 5. Normally we start from the left side. So see, 3 multiplied by 2 multiplied by 2 is here, same thing is here, right? 5 minus 3 is 2 factorial, and I have put only 2. Why? Because 2 factorial means 2 multiplied by 1, which is equal to 2. So that is why. If you will put 2 factorial, in the next step you will write down 2 is to 1, that is also fine. So here is 2 one time, then 2 time when you will make them more simplification, you will get 10. So there are 10 combinations, and here we have used the formula, right? Okay, move on. Difference between combination and permutation. Again, in permutation, order is required. In combination, no need of order. The difference between a combination and a permutation can be shown using the letter A, B, C, D. These are the permutations. See, A, B, first you have to make A, B, then A, C, then A, D, right? And this column is B, A, B, C, and B, D. Right? Similarly, third column CA, CB, and CD. So in permutation, order is important. A, B, and B, A. These are two different things. These are not equal. These are different. A, B is different. B, A is different because order is important. But in combination, AB and BA both are same. So see, AB and then BA. So we will cross out this. This is not the combination. Similarly, AC and CA both are same. This is same, 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 and then CB. This is BC, this is CB. So in order is not required. So simply you can say, when you will cross out the duplication from the permutation, you will get combination, right? So this is the difference between combination and permutation. In permutation, again, order is important. In combination, order is not important. From the permutation, if you delete the duplication, remaining is called the combination, right? So we have finished our counting rules, fundamental rule, permutation, and combination. If still you have any question, write down in comment section, and thanks for watching.